Good day for you all. You have completed your mid-semester exams. Now we have to finish our thermodynamics part also. So today we are going to analyze non-flow processes in closed systems. First we'll finish closed systems. What are the processes that can be taken place within closed systems that are known as non-flow processes? Now, what are the non-flow processes that we are going to analyze? There are 6 non-flow processes. Out of those 6, we are going to study 5 non-flow processes. Constant pressure process, which is isobaric process. Constant volume process, which is isochoric process. Constant temperature process, which is isothermal process. Polytropic process, adiabatic process. So most important thing in these processes are you have to understand each and every processes are important in actual scenarios. That means application of many industrial situations. So we'll see those individually. Constant pressure process. Another name, isobaric process. So, isobaric process. So, how do you remember this? Constant pressure isobaric. So, this is bar, isobaric. Bar is there because pressure is measured in bars as a unit. So, therefore, isobaric process. So, now, if you see this process or if you represent this process on PV diagram, you can see state 1 converted into state 2 through a horizontal line maintaining a particular pressure. So, same thing if you refer as an industrial application, you can refer the figure. You see, the figure belongs to state 1 with low heat. The here inside the figure, inside the vessel, you can see the square block with a small slide piston. There's a particular pressure which is visible in the pressure gauge. You can see the line or the indicator of the pressure gauge. Then same thing what happened after increasing heat, second state, the heat is increased. Heat is increased, then what happened? So you should have the same pressure in the indicator. Then what happened? But energy supplied as heat. The internal energy increased of the working fluid as the gaseous area. So what happens is the piston or the piston with the block moves down and increasing volume in order to maintain the same pressure, right? So this is same thing what is expressed in the PV diagram. State 1, the pressure is P1 but volume you see V1, which is little low. And state 2, you can see the pressure is same pressure even at state 2 in the horizontal line, but volume is increased to a V2 here. Okay, the volume is increased. It is visible with the figure as well as the graph. Okay. Similarly, we'll see constant volume process. Constant volume process can be identified as isochoric process. Another name for constant volume is isochoric process. You have to remember that. isojoc. This is a Chora process, therefore isochoric. Now, but you just remember, constant volume process is identified as isochoric process. Now, here you see, if you represent a constant volume process on PV diagram, then there is a line, but volume should be same. Therefore, line should be vertical. Why? Volume should be same. Then state 1 converted into state 2 as shown in or as represented in the or as drawn in the PV diagram. So state 1 at below with lower pressure, and state 2 the pressure is increased, maintaining same volume at the state 2. Then if you see simple industrial application, it is like this as shown in the figure. You can say low heat. Heat is little low and a particular volume V1 is maintained in the vessel, we'll say rigid vessel. So the indicator for the pressure P1 you can see. So after reaching for the second state, you can see high heat. You increase the heat input. So what happens? The heat is absorbed by the working fluid inside, maintaining V1 is equal V2, but the internal energy is increased within the working fluid or the substrate, right? Then that that heat, that energy within the working fluid is visible as increased pressure in the pressure gauge. The volume is constant but pressure increased. So then low pressure state to a high pressure state. Now I think it is very clear, you understand. We studied theoretically as well as physically about two processes, constant pressure process and constant volume process. Now, this is our target now. We are going to analyze non-flow processes in closed systems. Right? Now we are going to move forward with solving problems. How do you do this? It is very funny. You can do it easily. So, with upcoming videos, you will enjoy in solving questions. Okay. Have a good day. We'll go forward with videos.